Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
This episode is proudly sponsored by Metageek. For more than a decade, network professionals have used Metageek Wi-Fi tools to deploy, maintain, and troubleshoot wireless networks. Visit metageek.com/CTS and use the code CTS10 at checkout for 10% off your purchase of Metageek brand hardware and software. Hey everybody, welcome to a brand new episode of the Clear to Send podcast. This is the first one of 2018, so I want to welcome you to a brand new year. I hope you guys had a great holiday. Spent my Christmas, the end of 2017, down in San Diego, so I opted for much warmer weather, and it was a lot warmer than I thought it was going to be. I think it was just shorts and flip-flops weather, not too cold at all, which was great. Lots of sun, and spent time with my family there. We were able to open up gifts and check out the city. I used to live there for quite a bit, so me and my wife went out for a couple of date nights and had some great food, and then came back to San Jose and spent New Year's just at home. Just watched the countdown in New York and saw everybody freezing. And hats off to you guys out there on the East Coast braving this storm. It's crazy. So hopefully this new episode will give you something to do, hopefully provide you some warmth somehow. And I just want to welcome you guys to the brand new year, brand new episode. So we'll see what we're going to come up with for the Clear to Send podcast. And today, it's just going to be me, your host, Roel Dionisio. Francois is actually in Europe. I think he's in France, so he's enjoying his time there with his family. In this episode, we're going to talk about Cisco NDP, the Neighbor Discovery Protocol, which is used in the Cisco wireless controllers. Before that, though, we had a contest that we did near the end of the year in December. We were giving away the CWNP library, and we were also giving away the Ventev VenVolt, that orange juice pack. It's the battery, the new battery that you could use for these more powerful APs, these more power-hungry APs. So we have two winners. Our first winner is Jeffrey Borish. He is going to get the CWNP library. So we're talking about the CWNA textbook, the CWAP, CWDP, and the CWSP. Those are the official study guides that he's receiving. I've already sent that his way. He might have gotten a couple of them already at his doorstep. So Jeffrey, if you hear this, hopefully you're going to enjoy those books. I know it was good timing for you because you're studying for the CWNP exams. I think you're starting on CWNA, so that's great to hear. I hope you find those very useful for your studies, and good luck. Keep chugging along, keep learning, get some labs up there, put up an AP, start looking at wireless frames using Wireshark on your Mac, or, if you have a Windows machine, you could use the adapter, the name, it's escaping me right now, AirCap PNX. That's what you need so you can capture frames on your Windows PC. And then our second winner, the winner of the VenVolt, that is going to Brian Takeuchi. Sorry if I butchered your last name there. And I think he's from Hawaii. So awesome. This VenVolt will be great for surveys. And they just came out with this. A whole batch went out. And I noticed on social media some people were already starting to receive that. So that's great. And this will be useful for you if you're going to do some surveys, or maybe you need to power up an AP. Who knows? You can even charge your laptop or your phone on this thing. There's so much juice. So congratulations to the two winners of our contest, our first Clear to Send giveaway, Jeffrey and Brian. You guys enjoy those prizes, and I will follow up with you guys to see how that worked out for you guys, and looking forward to your responses. As always, with a brand new year, people have their predictions, and I thought this time around, I'm not going to do any predictions because I just decided that predictions are dumb. They're stupid because it's not really a prediction, but more like guesswork, right? The only predictions I'm going to make is going to be talking about what I can control, which is this podcast. So we are hoping to provide a lot more better content for you guys, hopefully more on the educational side. And we will also bring in more interviews. Because if you guys haven't heard of the survey that we also were pushing for end of last year, we had over 60 responses on our survey about helping us deliver the right content for you guys, something that's relevant. And so I wanted to share some of those results, just some of the good stuff, and primarily around the content that people want to hear. And so it was around what I figured people wanted to hear. Educational content is what people want to hear the most. So you want to learn something. You want to, get that certification. So maybe some educational content regarding the CWNP certification or maybe another vendor certification. So we'll start working on some of that and delivering that kind of content to you, especially something like this, where in this episode, I'm going to talk about the neighbor discovery protocol. And that's something that I've learned out on my own, going through some of Cisco's documentation, then trying to validate some of that documentation with what I see with the equipment that I have, using frame captures, that kind of thing. So I'm going to share what I know, what I've learned over to you guys in the form of educational episodes, educational content. And also, Francois is a trainer. He is much better than I am when it comes to training people. Hopefully he can provide some content as well with what he knows very well. And we're looking forward to doing that because it is our goal to be as educational as possible for you guys. So you come or you finish listening to this episode and you take away something that you could use out into the real world. The second type of content that people really wanted to hear about are interviews. And we got some feedback from this. People said they really enjoyed the people we brought on, the types of interviews we were conducting. So we're going to try to increase the number of interviews, bring in different kinds of people that you may not know about. Maybe they've done a couple of interesting projects. And so we want to share that knowledge out with you guys because there are a lot of people in our industry, other Wi-Fi professionals, who may not have a blog or like I said, you may not know about them. They may not be on social media, but it'd be a great way for them to talk about some of the interesting projects that they've been working on. And one of those interviews that comes to mind was somebody who did a Wi-Fi project for the New York subway system. And so that is an example of some of the interviews we want to bring on. The third most popular, actually the third and fourth most popular type of content people wanted to hear were roundtables and news. Both of those came almost close to a tie. So roundtables are interesting to get people's different perspectives, get a good dialogue going between 2 to 3 people. The last time we did a roundtable, I think there were way too many guys on the call, and conversations start to drift and get kind of messy. So when it comes to the roundtables, I think we're going to keep the roundtable very small, maybe 4 people max, and then have a very specific agenda to talk about and kind of bring the a relevancy there with the roundtable. So if you guys have any ideas of what you want professionals, other Wi-Fi professionals to talk about, feel free to reach out to me or Francois and let us know what topic you want discussed in a roundtable. And when it comes to news, we do want to bring back the news. We've brought it into a couple of episodes, but we don't do it consistently. So we're playing around with some ways to organize the news as it comes out. I'm not always on social media and watching the news because I'm a pretty busy guy. And sometimes when I do see the news, it's already been discussed upon or it's a little too late, and which is why I don't typically share it that much. But, I'm going to get rid of that mindset and just say, okay, if I saw this, I'll add it to my list of news that I want to share out with everybody, and we will talk about it on the podcast. So we might not go into a deep discussion about the news, but simply just stating what news came out recently that we've heard about. So just wanted to share those survey results with you guys. For those of you who have filled it out, I appreciate you guys for taking that time to let us know what you guys think, for giving us some constructive feedback there so we can help improve this podcast for you guys and provide more relevant information, make it more interesting for you guys. And if you guys have any other feedback, just feel free to reach out to us on Twitter at ClearToSend, or you could always message us through the contact form on the website. So I want to get into the main topic of this episode, which is Cisco NDP, or Neighbor Discovery Protocol. It's another acronym that we need to know. And the reason why I wanted to bring NDP into this episode is because in the future I want to talk about RRM, and specifically Cisco RRM, and then we'll dive into other vendors' form of RRM. But when it comes to RRM, I think the best place to start is the Neighbor Discovery Protocol, or Neighbor Discovery Packets, because it's a very critical part of RRM, or Radio Resource Management. And in Cisco's language, it's the Auto RF feature. So the main purpose of NDP, Neighbor Discovery Protocol, is to provide over-the-air messages to other access points that are in the same group, RF group or neighborhood on the controller. And so these Neighbor Discovery Protocol packets, they're used to monitor and manage what each of the APs are seeing in the RF space. So it's what I say is, or the way I like to put it is, it's NDP is a way for APs to build a map of their locations in relation to each other based on the RF propagation and also the path loss that you can get through NDP. And so we'll go into that a little bit further. So NDP, these packets that are sent over the air, by default, they're sent every 3 minutes. And when you look at the configuration, it's actually 180 seconds. So the AP will send an over-the-air message to a multicast address that is 010B85000000, and it sends it to that multicast address on each channel. Yep. So that over-the-air message, the NDP, is sent from each radio, the 2.4 and the 5 gigahertz radio, and then on every channel. So the NDP messages are also sent at the highest transmit power. In addition to that, it's sent at the lowest data rate supported for that channel that it's being transmitted on. So that transmit power and data rate selection, that part is actually not configurable by you guys at all. That you won't see that option in the controller. But for the interval at which the NDP is sent, that can actually be changed, although it is a default setting, and Cisco recommends not changing that default setting. So the NDP, Neighbor Discovery Protocol, is the basis of many of the algorithms that Cisco RRM uses. And so I think it goes without saying that NDP, if it doesn't work, RRM is not going to work. And so, I can link out to RRM, the white paper, which is a good read for you guys if you haven't read it. But NDP is used by the following algorithms: the RF grouping algorithm, transmit power control, or TPC, FRA, flexible radio architecture, and that is that it uses NDP for the basis of coverage overlap factor. Rogue detection uses NDP, and the way that rogue detection uses NDP is if if an AP isn't sending NDPs or the NDP cannot be understood, then the controller will classify that AP as a rogue. This episode is proudly sponsored by Channelizer and WiSpy DBX, the professional spectrum analysis toolkit from MetaGeek. If you're a professional in wireless networking, you know that the most frustrating Wi-Fi problems are the ones you can't see. Trying to diagnose Wi-Fi problems without having a clear picture of your environment is nearly impossible. Channelizer and WiSpy are purpose-built to give you that clear picture. WiSpy scans both the 2.4 and the 5 gigahertz Wi-Fi bands, and Channelizer renders that data into an easy-to-read visualization that will show you the Wi-Fi and non-Wi-Fi interference plaguing your network. If you need to quickly identify and eliminate interference in any wireless environment, from small business to enterprise networks, Channelizer and WiSpy DBX will help you get the job done. To thank you for supporting our friends at Clear to Send, MetaGeek is offering a limited time 10% discount to all listeners. Go to metageek.com/CTS and use the code CTS10 at checkout for 10% off your purchase of any Channelizer and WiSpy DBX bundle. Clean Air also uses NDP, and that's used for interference reports. And for you guys that use CMX, NDP is used in CMX, and that's used for the RF distance and path loss measurements. So just from that list alone, you can tell that NDP is very important to RRM. So if you misconfigure the settings for NDP, there's not that many settings to configure, but if you change it from the defaults, not sure what it could cause, what changes it can cause for RRM, that could screw it up. And so the NDP packet, which is sent out every 3 minutes, what's inside of that packet? What kind of information are each of these APs going to be looking at when it receives this NDP packet, right? So there's a number of fields in there. For one, there's the radio identifier, and that is going to tell a receiving AP that receives this NDP packet what radio it was sent on. Was it the 2.4 radio or the 5? There is also a group ID field, and that's the sender's wireless LAN controller, the IP address and priority code. There is a hash, which is the RF group name that is converted to a hash, and that's used for authentication, so you can authenticate these NDP packets. The IP address is a field, and that IP address is of the AP's RRM group leader. There is a field indicating whether or not that NDP is encrypted, because these can be configured to be encrypted. There is a version field, depending on what version of NDP it is. I'm not sure what version Cisco is currently on for NDP. There is a field name for AP channel. So whatever the operating channel is of the sending radio. So if you have an AP that is sending an NDP packet on its 5 gigahertz radio, but we know from earlier that the NDP packet will be sent on every channel, we want to know what channel does that AP actually serve clients on. And so that's what the field name AP channel is. There's also the message channel field, and that is actually the field populated for when the AP is sending the NDP packet. What channel is it sending on? So the AP could be serving clients on channel 36, as an example, but it may be sending out the NDP packet on channel 48. So that if it's sending it out on channel 48, it would place 48 on the message channel field, and then channel 36 on the AP's operating channel field. There's also a message power field, which is the power in dBm which the message was sent at, which would be its max transmit power, and then the antenna field, which is antenna pattern of the sending radio. So those NDPs are sent out every 3 minutes by the APs on either the 2.4 or the 5 gigahertz radio. What happens when another AP hears and successfully receives that NDP message? for one, it's going to validate that this message is coming from an AP that is the same member of the same RF group. And if it is valid, then that AP will take that message and it's going to forward it along to the controller with information that's important, such as the receive channel that it got that NDP from, as well as the RSSI, that signal that it received that NDP on. So the AP transmitting the NDP may send it at 20 dBm, but the receiving AP of that neighbor discovery packet may be receiving that at a much lower signal. So it's going to forward that information along to the controller. Now, if the message is not part of the same RF group, then it's invalid. It's not going to do anything with it. So with that valid message, that message is going to add the the message that the AP receives. It's going to take that AP that sent that NDP, and it's going to add it to the neighbor database. And that's a neighbor database that's on the actual AP itself. And each radio on each of those APs that receives NDP can store up to 34 neighbors. And I'm not sure if this information has changed recently, but from what I saw in the RRM documents, that it stores up to 34 neighbors and it orders it by RSSI from high to low. And there are two measurements that are actually taken from receiving these NDP. There is the RX neighbors, which is how that AP hears other APs. And then there's the TX neighbors, which is how other APs hear that transmitting AP. So that's kind of the gist of Cisco NDP, the Neighbor Discovery Protocol or Neighbor Discovery Packets. And it's critical to RRM functionality. And we want to know that it sends NDPs on each radio every 3 minutes to a very specific multicast address. And so when it comes to knowing that information, what can you do with it, right? So what is configurable on the wireless LAN controller as far as NDP goes? Well, you could change the NDP frequency. And this is the frequency by default of 3 minutes or 180 seconds, but it is recommended to keep it at this default. There is a second setting called the channel scan interval, and also this is set to 180 seconds. And so the channel scan interval, that's each channel dwell has to be done within 180 seconds. And then there is a third field called the neighbor timeout factor, and that is by default set to 5. And what you use this value for is used as a multiplier, multiplied by the neighbor packet frequency, and that is your timeout. So with a default of 180 seconds, for example, for your neighbor packet frequency, and a neighbor timeout factor of 5, you do 180 times 5, and you get 900 seconds. And so this is the value that is used to prune out access points from the neighbor list that are timing out. So if you have an AP that were to disappear from your network for whatever reason, it would remain on an AP's neighbor list until the pruning actually begins. So that's every 900 seconds or 15 minutes. So where are these 3 settings that you could change? In the wireless LAN controller, if you go over to the wireless section, and then go to either 802.11a and AC or the 802.11b, the 5 or 2.4 radio, go to RRM, and under General, there is a section there called Monitor Intervals, and you're allowed to use anything from 60 to 3600 seconds. Except for when it comes to the neighbor timeout factor, it's either going to be from 5 to 60. And then, of course, if something isn't working right, you could set auto those auto RF features back to factory default with a simple press of a button. And what I did to see these NDP packets, I took my lab controller, which is a Cisco 2504, and I put in a Cisco 3702 access point. And using OmniPeak, I put the adapter to capture on channel 64 and created a filter on the MAC address, which is the multicast MAC address. And I have a screenshot where it shows the first NDP packet and then the second one. So if you look at the relative time, it's about 3 minutes, for which we saw it's the default. And so you could see those frames going over the air at the maximum transmit power. I was able to see what signal strength I got it at and what channel. So if you're using this, right, you want to see what else the controller uses this information for. If you go to your controller and go to the monitor tab in the web interface, and then on the left side, you'll want to expand access points and then radios. You could then select your 2.4 radios or your 5 gigahertz radios, right? So pick one, for example, the 5 gigahertz radios, and then you'll see a list of your APs and their radios for that frequency. So if you go all the way to the right, you'll see that blue drop-down arrow. Hover over that, and then you'll get a menu pop out. And you want to click on Detail. And so when you click on Detail, there is going to be a section for that AP that you want to see the detail for, the RX neighbors information. And from that, you could see the AP's MAC address, the RF group leader ID, what channel that AP is transmitting on, and the channel width, as well as the RSSI value, the signal strength that AP is heard. So that's one way you could view the data of these NDP packets, which is really interesting. Now, the other way to do this, you could use command line. Command line will probably give you a lot more information, and it's going to be able to view nearby APs from the by using the command line interface. You're going to want to pick which AP you want to view this from. And so that command is called show AP auto-RF. And with that command, there's 3 options. There's 802.11-ABGN, which is used. That's going to be displaying information for dual band APs, the dual band 802.11-ABGN. There's the option for 802.11a, and then there's the option for 802.11b. Right. So the first option, that's for your FRA radios. 802.11a, obviously it's 5 gigahertz radio, and 802.11b is your 2.4 gigahertz radio. So, and as an example, you want to put in show AP auto-RF 802.11a and then the AP name. And then you'll actually see a list of nearby APs, kind of the same way as using the GUI, but then now you have this command line interface option. So I wanted to take this a step further, and I wanted to do some debugs. You can actually debug there's a debug command that allows you to view these NDP packets. So the command here is debug capwap RM measurements. And this command is actually performed or typed out on the AP itself. And so you're viewing this debug command and showing, it's going to display output of what channel NDP packets are being sent out on. And so with that output, you'll see quite a bit there, and it'll say something like neighbor packet sent successfully on channel 44. And then it's going to tell you what the next channel it's sending it on, channel 48. So that's one way to debug NDP, and that command, again, is specific to the AP, not on the controller. Now, when it comes to debugging, again, there is another debug command. We just talked about the debug command that shows output for sending the NDPs. What about receiving? So that command is debug capwap rm neighbor. And so that's going to enable your RM neighbor display and all the NDPs that it's receiving, including NDPs that are not in the same RF group. But then again, if it's not in the if it's not a valid NDP, it's just not going to do anything with it. But you'll see in this debug all of those NDPs come in, and some of that information will be the neighbor with the MAC address and what RSSI it heard it on or heard it from, and then also what channel it heard it from as well, and whether or not there's encryption enabled. And so I'll provide some of the examples of this on the show notes because I think it's really good information to see, especially when it comes to troubleshooting RRM. The first thing you want to know is how RRM works, and the way it works is it's going to use NDP packets because that is kind of the basis of all the algorithms. That is how each of the APs hear each other. That's how they come up with what power they're going to all be set to, what channel they're going to select, that kind of thing. So this is kind of the scratching the surface here, and I don't know, maybe I'll create a video showing some of these settings because it is sometimes difficult to just communicate it over a podcast because you can't see what I'm looking at. But head over to the show notes, and that's cleartosend.net, and you'll be able to see what I'm talking about when it comes to NDP. And when I started looking at this, I thought it was very good information to start fully understanding how RRM works. So again, head over to those show notes. It's cleartosend.net/103. That's where we'll have the show notes up for this episode. And I want to thank you guys for listening to this episode again. Welcome to the new year, 2018. We're looking forward to bringing you many more episodes. If you guys have any comments or suggestions, please reach out to me. You guys know how to find me, cleartosend.net, or on Twitter at cleartosend. If you haven't already, go ahead and subscribe to us in iTunes and also leave us a rating. Let us know how we're doing. When you subscribe to us in iTunes, the episodes automatically get uploaded to your listening device, your iPhone, iPad, whatever. And for us, this is a great time. We're wanting to really improve the show and provide more great information out to you guys. So I want to thank you guys for listening. We will see you on the next episode. You guys take care. Stay warm. Thank you, guys.